Welcome to the KYAI pod, the Know Your AI podcast. William has been working recently on getting the latest open weights model out of China, the famous Kimi K2 thinking model, which is kind of leading the open weights leaderboard right now. It's putting a lot of the leading labs in a competitive position relative to both the accuracy performance, and equally it's made headlines similar to DeepSeek around the cost of developing Kimi K2. They used a kind of not necessarily an old school quantization technique, but their precision is Nt4, which has been around the market for a while. So it's a trillion parameter model, so it's a huge model, but 32B active parameters. So they're kind of being surgical in what they actually deploy. William, I think, out of the box, the Kimi documentation mentioned the model server of choice, or one of the model servers supported was VLM. I don't think it worked for you out of the box. So give us a little bit of context on what didn't work out of the box when you got Kimi 2 up and running.
Yeah, so they recently just merged a build that supports the Kimi architecture because it's pretty brand new, with a new reasoning parser into VLLM, but there hasn't been a full release since 11.0, so only the nightly builds were working. But the issue was that between the time the model was released and that patch was merged, and when we were running our benchmark, which was maybe over the weekend, there were some changes made to the nightly build that didn't allow us to run it according to the documentation using VLLM. So we had to get creative and roll back a nightly build. And then we also initially were running using the DeepSeek parser, which was working fine. But these numbers here are with the Kimi K2 parser, with the correct nightly build, and running on B200s. So that's Blackwell Arc. So we've got a lot of brand new tech at play right here.
Yeah, no, it's great to see it, and thanks for powering through those compatibility challenges and working through the nightly builds. One other fun thing, obviously we're using our performance and eval product Metrum Insights for this, and you're running kind of a traditional hardware throughput and performance tests here. One of the interesting things is you selected our reasoning data set. So, you in Metrum Insights, you can go test a model based on, a traditional real world set of prompts that are randomly generated, but not random numbers. They're real prompts. And, but we also have a data set curated for reasoning use cases as well. So we can kind of test reasoning performance apples to apples on throughput, as well as you do on accuracy evals. And so you kind of fired up that reasoning data set on this as well. So B200 hardware, state-of-the-art, latest leaderboard open weights model, state-of-the-art, got the right parser on it, implemented the VLM nightly build, and you tested it with a reasoning-specific data set. So a lot of critical components to having a very valid performance benchmark in this particular case. So, how did it turn out, William?
Yeah, so we got some really, really, really good results here. So max throughput here was 8.7 thousand tokens per second, and that was at, I believe, 2048 concurrent requests. So that's a pretty solid number for a model of this size. And just for comparison, we were getting about 1,000 tokens per second less with DeepSeek 3.1, which was sort of the king of the hill before Kimi came out. And on your point about reasoning, Steen, that was before we actually implemented our reasoning-specific benchmarking props. So even with that reasoning overhead, we're still getting more token throughput. And it's a much larger model as well, about 300 billion parameters larger. So it's really impressive, to say the least, what they've done with their quantization strategy. The B200 by 8 cluster is a perfect size to run something with this memory footprint. You can see that there's a little bit of a drop off when you start to increase the input output token combinations, which are these points here. But that's generally due to the size of the model, and even with a cluster B200s, you're still pretty much hitting that GPU memory utilization cap. So yeah, this is obviously just a single cluster. So
So
yeah, very
you
impressive
deployed
results.
one replica in this case across all 8 GPUs.
Yeah,
Okay. Yeah, because of the memory footprint requirements on that front. Got it.
right, exactly.
And then time to first token. Any observations there?
Yeah, so pretty solid numbers here. For context, DeepSeek obviously a little bit faster, but we weren't testing reasoning. So now, even with the reasoning, it's only about 60% slower for time to first token, which is it's okay. I mean, generally speaking, you'd expect about 100% slower. So the efficiency is there, and once that first token is generated, it is actually a higher throughput model. So time to first token is about exactly where you'd expect it to be. It's a very solid showing here. It's actually a little bit better than you'd expect it to be. So performance wise, it's great. Latency wise, it's great. So that's really what you want to hear.
Fantastic. Well, William, thanks for pulling this together. It's great to see the latest state of the art open weights model running with a real valid thorough benchmark of reasoning, giving it those reasoning prompts as well, and on some Blackwell B200 by 8 implementation. So yeah, great insights, William, and appreciate you putting this together. I think people should be fired up around Kimi 2 thinking model, and kind of getting some insights on how affordable it was to deploy it. I think the other, besides the affordability, in training the thinking model, I think the other big aha moment is the deployment affordability and the API cost and that they're putting out in market. So definitely shocked in some of the big global labs, and the price of deployment as well as the price of development on this front.
Yeah, I also want to give a huge shout out to my coworker Aryan for the support with getting this up and running. Yeah, he's amazing, a phenomenal engineer, and yeah, wouldn't have done it without him.
Awesome, William. Well, thanks for checking in and seeing Kimi 2 up and running on a B200 by 8 system, and checking out some of these great performance results.